Hi everybody, these are the notes for 5.3 and 5.4 graphing exponential and logarithmic functions. They are in your notes packet on approximately page 11. Even though it's not numbered, it's before compound interest and after, what is this? Solving logarithmic and exponential equations. So we're going a little bit out of order here. Today we're going to be graphing exponential and logarithmic functions. I am not going to walk through all of these examples with you, but I'm going to do a few. On the front, we're just going to do a little exploring of what a graph of an exponential and a logarithmic function would look like, and then on the back we'll actually start graphing them ourselves. So if you look on the front page, the directions say to write the coordinates of the points that are plotted on each graph, and then write the equation of the asymptote. So the idea here is really to make sure everyone's clear on why we get the asymptote we get when we're doing our graphing an exponential equation. So I like to start here at the beginning when x equals 0, and so you can kind of imagine plugging in and you get 3 to the 0, and anything to the 0 power is 1 here. So our first point would be 0, 1. And then when x equals 1, we would get 3, 2, 9, 3, 27, all the way up to 4, 81. So those are hopefully pretty easy to see. Now let's look at the negative ones, though. When you plug in 3 to the negative 1, that's like 1 over 3 to the 1, which is 1/3. So over here, when we plug in negative 1, we're going to get 1/3. When we plug in negative 2, we're going to get 1/9. And when we plug in negative 3, we'll get 1/27. And plugging in negative 4 gives us 1 over 81. So it's basically the reciprocal of all of the other points that we had over here. So I'm going to pause for a second and I ask you to pause and try numbers 2, 3, and 4, and then come back and we'll make some conclusions about the graph of an exponential function. So I'm going to trade that one out for one that's already been done here, so you can check your work or look on with me. For all of these, you should notice when you're graphing them that your graph is going to get, as you go to negative infinity, these fractions are getting tiny, 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 but they're always positive. They don't go into the negative realm down here. So our asymptote here is that y equals 0, and our graph is going to get infinitely close to y equals 0, but it'll never actually touch it. And that should have been true for all of your graphs that you did. Also, for all of these, they should have had an asymptote at y equals 0. So if you'd like to check over the work here, you can. And then I'll move this down also. Again, an asymptote at y equals 0 and an asymptote at y equals 0. Now I do want to point out that this one is different. This graph looks different from the other ones. The other ones all start off at y equals 0 on the left, and then they're going to get really big really fast as you go to the right. This one's the opposite. This one starts off really big, and then it approaches the asymptote as you go to the right. So it looks like a reflection of one of these. The difference between these two is that this one has a base that's greater than 1. And this one has a base that is less than 1. So because this is a fraction, this is actually an example of exponential decay instead of exponential growth. So this one is going to be decreasing because our base is between 0 and 1, right? So like that. Okay, so next let's look at logarithmic functions. So that would be 5, 6, 7, and 8 down on the bottom. And so these are a little bit more challenging to do, I think. It takes a little while to kind of wrap your head around, at least for me. So if you look at number 5 here, we're going to be labeling the coordinates for the points of log base 3 of x. And so the way I like to think of this is like 3, like to say log base 3, for example, let's start pretty easy. Let's start at log base 3 of 9. So that one's pretty easy. That equals 2, right? So that means when x is 9, my y is actually 2. It's sort of the reverse of what you might think of what you're used to. So this is my x and this is my y over here. So I have 9 comma 2 as one of my points, and that'll be right over here. Okay, so what if I had log base 3 of 27? That would equal 3. So now my x is 27 and my y is 3. So that's this point right here. And you can even go all the way over here to 81 comma 4. Okay, what about some of these over here, though, some of these smaller ones? So log base 3 of 3 equals 1, like that. So we have 1 point at 3 comma 1. And then we also have this one right here, log base 3 of what equals 0. Because 3 to the 0 power equals 1. So this will give us 1 comma 0. And basically what we're doing here is we're picking, usually we pick easy values for x to plug in, but what we're doing here is picking easy values for y. So now let's go ahead and think about if y was like a -1 over here. So 3 to the power of -1 is 1/3. So my x would be 1/3 and my y would be -1. So that's going to be this point right here, 1/3 comma -1. One-third comma -1, and then we would have 1/9 -2 and 1/27 -3. And I know those are kind of hard to see, but that's what these points are. And the idea here is to notice that we are going to have an asymptote right here. So this graph is going to get very, very, very close. The x values are getting teeny, teeny, tiny. They're approaching 0. They're not actually going to equal 0, but they are going to get infinitely small as we let our y values also get small. So our asymptote here is actually at x equals 0, not at y equals 0. Because it's a vertical line right there where x would equal 0. Okay, so I would ask you to pause now and then do 6, 7, and 8, and then I'll show you the answers to those. Okay, so for 6, 7, and 8, all of them should have, 6, 7, and 8 should all have an asymptote at x equals 0. For this one, you're going to have various powers of 2. So if you let your y's pick easy values for y, like -3, -1, 0, 2, 3, 4 here, your x values are actually the ones that are going to be a little bit more challenging. Same idea down here with these. Pick nice easy values for y, and your x values are going to be the ones that are different. And then on this one, it's also, you still have an asymptote at x equals 0. You still have nice easy values for y, but you'll notice here again, this one looks different from the other 3, and that's because again we have a base that is not greater than 1 here. So that's what makes this one an exception. And that's why it looks like it has been flipped a little bit here. So it looks like this has been flipped over the x-axis, whereas with the exponent one, it looked like it had been flipped over the y-axis. So instead of growth here, we actually have a decrease here also. So the basic idea here for graphing exponential and logarithmic functions are the asymptotes and the general shape. So in general, like a parent graph of an exponential function of exponential growth has an asymptote at y equals 0. It starts off with very slow growth, and then it kind of hits a tipping point and takes off and grows very big, very fast. So that's your general form of an exponential function. For exponential decay, it is basically the same thing, just flipped. Now for a basic shape of a logarithm, it has its asymptote at x equals 0, and it's sort of the opposite. It starts off growing really, really fast, and then it sort of tapers off and becomes, it's still growing, it's still getting bigger, but it gets bigger much, much, much slower. So let's look at how to graph some of these with transformations on them. They're the same types of transformations you do with parabolas or any other parent function. And we're going to go in the same order that you would go in with parabolas or any other function. So if you look at number 9 here, we have a few different transformations happening. We are going to have a reflection here because of the negative. It is going to be shifted left 3 and up 2. All of those things are going to happen. We're going to start off with a parent function, graphing 7 to the power of x, and then we're going to take the transformations one at a time. So for our parent function, f of x equals 7 to the x power. And you don't have to do a ton of points. Let's say 3 points. So 7 to the 0 is 1, 7 to the 1 is 7, and 7 to the negative 1 is 1/7. So that would be like down here. And that's our parent function that we're going to be working with. Okay, next, if you remember the order that we go in, the big thing to remember is to do your shifts last. That's the really important thing. The stretch is sort of built in with what our base is. 7 is our base, and that means we're kind of stretching by a power of 7. We don't really have a parent function for this because if you plugged in 1 to any power is just 1, so it wouldn't look any differently. So our stretch is pretty much built in, but remember our order is first you want to stretch, then you want to flip, and then finally you want to translate, or you want to shift. So next we're going to flip this one over, and this negative is in front of the entire function, so the entire function is going to get flipped over. So when I draw my axis, I'm going to actually give myself a little bit more room up here. So our f of x is now negative 7 to the power of x, like that. Sorry, it doesn't have a parentheses around it. Scratch that. Negative 7 to the power of x. 7 to the 0 power is 1, so this is going to give us negative 1. 7 to the 1 power is 7, and make it negative 2, 3, 4, 5, 6, 7. And then our negative 1/7 over here like that, and it's going to be flipped over like this. Okay, next we're going to shift, and it sort of doesn't matter if you want to shift left and right first or up and down first. It's not going to change your answer, or you can do it all at the same time, and I'm actually going to do that just for the sake of time a little bit. So again, I'm going to give myself just a little bit more room with my axis here. And one thing that I want to note is that before my asymptote was here at y equals 0, now I'm shifting it up 2. And so my asymptote is going to be actually at y equals 2. And I'm going to use that just to help me make a nicer and prettier graph. So for this point here, that used to be at 0, negative 1, it is now going to go left 3, up 2. And this point here that used to be at 1, -7, so this point right here, is going to go left 3, up 2. And this little guy right here, who used to be at -1, 1/7, is going to go left 3, up 2. About like that. And then go ahead and sketch your graph. And so this is our final version of -7 to the power of x plus 3 plus 2. Now for a logarithm, similarly, we're going to start off with our parent function, just a kind of base, log base 4 of x. We're going to start with that and then transform it one at a time. So for this guy, with the log base 4 of x, we're going to have a stretch of 2. It is going to be reflected, and it's going to be shifted down 3. So we're going to be looking at 3 different transformations here. So start with log base 4 of x. And remember, for this one, you kind of pick easy values for y instead of easy values for x. So if this is like your y equals, maybe you choose 4 to the 0 power equals 1. So we'll have 1, 0 as a point. And then 4 to the first power equals 4. So that would be an x of 4 and a y of 1. If I wanted to go over 16, I could go up 2, but I'm going to run out of room on that one. So instead, let's pick, for y, let's say -1. So 4 to the -1 power is 1/4. So going over 1/4 and then down 1 like that. And actually, I need to make this grow a lot slower. Because remember, I didn't have enough room for 16. Okay, let's stretch to log base 4 of x. I'm going to keep my axes the same. That's fine. My asymptote is still going to be here at x equals 0. That doesn't change. And this intercept right here isn't going to change either. That's kind of your like anchor point, the one that doesn't change. However, this one is now going to be twice as tall, and this one's going to be twice as low. So when I go over 4, I'm going to go up 2. And when I go over 1/4, I'm actually going to go down 2 this time. Okay, next we are going to reflect. And this time the negative is in front of the x instead of in front of the entire thing. So when that happens, instead of flipping over this way, we flip over the y-axis. So I'm going to change my graph to have my x over here, my y over here, so I have a little bit more room to graph this. It's going to be the exact same thing that it was over here, just on the other side. So this point is going to go right here. And then instead of going to the right 4 up 2, I'm going to go to the left 4 up 2. And instead of going 1/4 on this side, I'll go 1/4 on this side. And remember, we're down 2 now because we stretched it. Still have this asymptote over here at x equals 0. And then the last thing we need to do is shift it down 3. So this is going to be our f of x equals 2 log base 4 of -x minus 3. So let's see. So this guy is going to come down 3. This guy, I left out. I didn't give myself enough room on the grid. It's fine. And then this guy is also going to come down 3, so he will be at -1. 1, 2, 3, 4, -1. Okay, and there's your transformed logarithmic function. This one, we didn't shift it left or right, so the asymptote stays at x equals 0. Of course, now it's approaching x equals 0 from the left instead of from the right. So I'd invite you to pause now and try the last two. One thing I do want to point out for this, for number 11 here before you graph it, is that this is like having -3 to the negative x minus 1 plus 4, like that. So when you shift it, you actually are going to end up shifting it to the right one instead of to the left one. So flip everything first, but then after you flip, you're also going to shift it to the right one. So it's important to factor out this negative before going ahead with your graph. So you can pause now and try number 11 and 12. And these are the answers that I got. So flipping, I flipped over the x first, and then I flipped over the y. You could have done it in a different order, that's fine. And then you want to shift right 1 and up 4. So now your asymptote is actually at y equals 4 because of that shift up here. And then for number 12, we actually have a shrink here, so it gets like squished down a bit first, and then flip over the x-axis, and then left 5, and then down 3. So we actually end up shifting our asymptote from x equals 0 to x equals -5 over here, like that. So that's graphing exponential and logarithmic functions. I hope it was helpful, and see you soon.